Taking a look at number 5, I'm going to first see, is it possible that I can factor the numerator and factor the denominator? I already see that the degree in the numerator is 3, the degree in the denominator is 2. When the degree in the numerator is 1 greater than the degree in the denominator, we know there's going to be a slant asymptote and no horizontal asymptote will exist. So let's see if we can factor this. I factor out an x squared, and I'm left with x minus 1. There's x cubed minus x squared. I write down the x minus 1, and I'm looking for a quantity I can take times x to achieve negative 4x. So negative 4, multiply and multiply. So I can factor by grouping to get x minus 1 times quantity x squared minus 4. Now I know x squared minus 4 is equivalent to x plus 2 and x minus 2. So the numerator is now factored or rewritten into an equivalent x minus 2 times x plus 2 times x minus 2. In the denominator, what multiplies to give you negative 3 and combines to give you negative 2 would be negative 3 and 1. So x minus 3 and x plus 1. I have rewritten the original function. I know there's a slant asymptote. I'm now going to achieve what is that slant asymptote. So x to the third, x to the second, x to the first, x to the 0. X squared times what is x cubed? And the answer is x. So each one of these columns, this only contains x cubes, x squareds, x's, and constants. All right, so I'm going to multiply to get x cubed. I'm going to multiply to get negative 2x squared. I'll multiply to get a negative 3x. Change the sign of everything in the second row, and now combine. These cancel, and I have 1x squared, a negative 4x, and a positive 3 provides me with a negative 1x, and I bring down the 4. X squared times what is 1x squared? It's going to be a positive 1. X squared minus 2x minus 3. Change signs. And then the thing is we don't really care what the remainder is. Remember, all we're trying to achieve is what is the equation of the slant asymptote. So y equals x plus 1. I'm starting at 1. The slope is 1 over 1. So up 1 over 1. I'm going to put it on pause, and I'm going to illustrate these. Okay, so I have the slant asymptote. Now let's look to see, is there a vertical asymptote? Remember, there is no slant, also known as oblique asymptotes, and that's because the degree on top is 1 greater than the degree on the bottom. Now, we can look at the denominator. If the denominator has a variable, we're able to identify the vertical asymptotes. In this case, we're going to set both of these groups equal to 0, and I'm going to solve. So I have one equation of x equals 3 and another of x equals negative 1. Graph those on my graph. The next thing I'm going to do is I'm going to identify if there's any x-intercepts. Each one of these groups will now be set equal to 0. When I set this equal to 0 to solve, I get an answer of 1. I'm going to go to positive 1, and I'm going to identify the x-intercept. Excuse me. Set this equal to 0 and solve, and I get an answer of negative 2. Set this equal to 0 and solve, and I get an answer of positive 2. Okay, so what I'm looking at here is I need to also do what is the y-intercept. So with the y-intercept, we set all x's equal to 0. So 0, 0, 0, 0, 0, and I'm left with 4 over negative 3. So my y-intercept is 0 and negative 4 thirds. That's like negative 1.1 repeating. Okay, there's 1, negative 1.1 repeating. And that's enough sufficient data points for me to see what this looks like. So there's my bottom. I already have 1 point out here. I can see this is my side. And now I have one more to do, and that's going to be, is it up here in this region? Is it over here in this region? So we need to have a point. I'm going to go 1 to the right of the vertical asymptote at 3. So I'm going to choose 4. I'm going to choose 4, and let's see what the output is. All right, I think instead of plugging into this and doing the math, I think it's much easier to do this math. So I have 4 minus 1 is 3, 4 plus 2 is 6, 4 minus 2 is 2, divided by 4 minus 3 is 1, and 4 plus 1 is 5. So 18 times 2 is 36. 36 divided by 5. So let's get an idea of what 36 divided by 5 is. Well, 36 divided by 6 would be 6, so 36 divided by 5, an even smaller we can see is about 7.1, so approximately 7.1. Okay, so here is, I'm at 4, I'm going to go 7.1. There's 2, let's see, 1, 2, 3, 4, 5, 6, 7. 7.2 is right there. Tells me it is up in this region.